Hello, everyone, and welcome to our webinar, LG Onboard Future In-Cabin Experiences Beyond Mobility with Empathetic AI. We are delighted to host this session for you today. Let's start with a brief introduction about us. I'm Youngkyung Gaines. I'm leading ADAS and vehicle intelligence development at LG Electronics. And besides me is Dr. Minkyu Kim, who spearheads our advanced development within ADAS and vehicle intelligence. So this is the agenda for today's presentation. First, we will address the core challenges for existing in-cabin solutions and present our derived solution to these challenges. And next, we will introduce the core technologies that we possess and briefly detail our approach to evolving in-cabin functionality from safety into experience. Finally, we will conclude our session by sharing our future direction and roadmap. With that, let's move into our first session, the core challenge and our solution. Undeniably, market safety regulations are becoming increasingly stringent globally. Consequently, in-cabin sensing is not just popular. It's becoming more and more critical, serving as the foundational start for in-cabin AI. Nevertheless, as the AI era accelerates, there is a clear and parallel demand. Consumers are expecting diverse, immersive in-vehicle experiences, as highlighted by the market trends we see today. Now, let's quickly look at the current foundation of in-cabin sensing. Today's landscape is primarily regulation-driven and component-centric, focusing on a basic driver monitoring solution and also interior monitoring solution. So especially in Europe, General Safety Regulation, GSR, is mandating driver monitoring to effectively mitigate distraction and drowsiness. Similarly, Euro NCAP continues to heavily reinforce in-cabin safety within its evaluation protocols. Detecting seatbelt misuse and precisely recognizing driver-passenger ports are prime examples of these mandates for future NCAP. Our existing LG electron safety solution fully covers these fundamental requirements. Beyond this compliance, we are actively expanding into areas like vital sensing and impaired driving and next generation in-cabin safety. So, while these core technologies are absolutely essential and serve as the baseline for safety compliance, we must acknowledge that they still exhibit some technical limitations to extend from safety to convenience, especially with the four major limitations. First, the current system are not fine-tuned to individual characteristics. They cannot reflect the differences in driving habits, personal preference, and specific safety needs for each unique user. Second, each function only operated according to a predefined static rule set, resulting in limited coverage and adaptability. This makes the system inflexible when faced with the unexpected or novel driving scenarios. Third, lack of proactive suggestions. The system still remains largely passive. It lacks the capability for proactive action or personalized suggestion before user explicitly triggers a function or an event occurs. Lastly, the system often relies on unimodal input or short-term data, which can lead to incorrect inferences in complex situations. So given these current technical limitations, the essential question is what key requirements must we satisfy to deliver in-vehicle experience that truly moves beyond safety? The real technical challenge is not merely integrating data, but achieving a deep understanding of the user context. Then let's take a look at the current requirement first. The current requirements are fundamentally focused on driver and passenger safety. In this perspective, high standards of accuracy, reliability, and latency are required. On top of those requirements, our upcoming requirements must be empathy, which is able to do proactive suggestion based on driver understanding. To achieve this paradigm shift, we've established the key additional requirements for the next generation of in-cabin systems: intention understanding and context awareness, which can interpret user intent by considering the overall context rather than fragmentary data, and finally, personalization to maximize user experience. So this slide shows our answer for upcoming requirements as the overall system architecture. It consists of recognizer, inciter, and illustrator. We will explain about this architecture in later section. So prior to a detailed explanation about our new approach, it would be very important to first acknowledge the legacy which will underpin this innovation. I will briefly touch upon our existing in-cabin sensing solution, which forms the technical foundation for our empathetic AI. So this is where it all begins. Field-proven in-cabin sensing solution. Our driver and interior monitoring solution is supporting NCAP and safety regulation with the highest level of accuracy and reliability. Driver monitoring can detect driver drowsiness and distraction by understanding driver head movement, eye gaze. Interior monitoring solution can understand driver and passenger behavior and pose. Also, it also can detect seatbelt, child seat, hands-on wheel, which are critical for safety. These technologies are evolved based on data excellence, which consists of synthetic data, real data based on ground truth system, and machine learning operations. So now let's detail our existing safety assets. As I walk you through these established technologies, the key point I want to emphasize is this: the resulting outcomes and technical characteristics of this solution form the foundational building blocks for our empathetic AI. They are not separate systems, but the essential prerequisites for our future platform. Our first core safety asset is the driver monitoring system, DMS, which detects driver drowsiness and distraction by precisely perceiving head movement, and eye gaze. Achieving a truly superior DMS requires 4 critical aspects. First one, high accuracy. We achieve the highest level of accuracy even when utilizing affordable camera resolution. Unlike exterior sensing for the driving, so in-cabin sensing faces the significant challenge of interpersonal variation, primarily stemming from diverse personal appearance, accessories like glasses or hats, and individual behaviors. As you can see in this video, our DMS delivers the lowest interpersonal variation. The system is also designed to have a high stability across a wide array of harsh environmental conditions, like a strong sunlight and heavy occlusion. Finally, by considering OEM needs, the system is designed to be applicable to various camera mounting positions. As you can see here, A-pillar, dashboard, cluster, rear view mirror, CID, steering column, so all kinds of location. So we are designed. Also applicable to different infrared configurations within the vehicle cabin. Next, our next core foundation, IMS, interior monitoring system, which can also detect body pose and behavior. This system utilizes highly accurate 3D body tracking to enable detailed analysis of both driver and passenger behavior and sitting pose. Crucially, this technology will be directly leveraged to comply with the upcoming Euro NCAP 2026 for out-of-position detection. Specifically, it will verify whether the driver and passengers are in a dangerous pose at the moment an airbag deploys. Ultimately, this 3D body tracking capability is essential not only for submitting mandated safety standards, but also for providing the granular positional data required for our advanced personalization features. Next, also one of the key features for the interior monitoring system. So various driver and passenger behaviors are also recognized by understanding the interaction between body and object, like calling, drinking, smoking. This kind of representative unsafe behaviors can be also recognized. Also, next one is also one of the key, other also key features for the interior monitoring system, seatbelt detection. So as you can see the left side of the slide, there are various cases of seatbelt misuse cases. So our camera-based seatbelt analysis enables detection of incorrectly buckled cases which cannot be covered by buckle sensor. This is a Face ID. So this is a major feature for the personalization. So camera-based, we are bringing camera-based facial recognition technologies, which can provide reliable Face ID performance. So this is quite robust to environmental changes. And also it also provides secure storage of biometric information. And also it also provides superior spoofing detection, also highly optimized for various platforms. This is one of some very new features, viral sensing. So we call it some DMS-based viral sensing. But before going to the details of technologies, why viral sensing? The RPPG, remote photoplasmography signal extracted by our solution is very rich with critical physiological information. Beyond basic health monitoring, such as measuring heart rate and the heart rate variability, this data becomes the core determinant for highly advanced capabilities like impaired driving detection and the sophistication of drowsiness detection. It is the essential layer that elevates the cognitive awareness of our empathetic AI. Why diverse methods exist for viral sensing? The most significant advantage of our solution is that it requires no additional hardware or dedicated sensors. We simply leverage the existing in-cabin camera that's already mandated by regulation. This approach dramatically maximizes both cost efficiency and integration ease. So this kind of technology, which I explained so far, is supported by some data. So without good quality of data, this technology cannot bring some full performance. So we are taking two types of different data, so real data and synthetic data. So real data is collected using some sophisticated GT system, ground truth system, and also synthetic generator, we bring in some generative AI. So among these 5 images, can you discriminate between synthetic data and real data? So many people, I examined to many people, but most of people cannot exactly give some clear answer for that. So as you can see here, some AI marked image is generated by our synthetic data generator. Based on that, using this kind of data can be augmented, and then finally some technology can be greatly improved. And then so this kind of data also also our model is trained using our MLOps environment. This is fully automated environment. So our MLOps environment bring fast model training and deployment, and also increased resource utilization. Also, it can reduce human error greatly. So we have now walked through the core safety assets of LG in-cabin sensing solutions. As I previously emphasized, these technologies are designed to do much more than simply satisfy current safety requirements and NCAP protocols. These existing elements serve as the indispensable foundation upon which we will realize the future of in-cabin experience, so-called an empathetic companion experience powered by multimodal fusion, contextual understanding, and hyper-personalization driving superior safety and convenience. So to detail how we translate these assets into our future vision, I will now hand the presentation over Dr. Kim.
Yeah. Okay, thank you, Dr. Bach. Okay, here we go. Like many OEMs, we also start with one fundamental question. How can we deliver an in-cabin solution that goes beyond the safety? One that is differentiated, cost-efficient, and create a human-centric, let's say, or even me-centric interaction. This question is at the bottom line of everything that I'm gonna share with you today. Now, imagine you are inside of your car, and the car doesn't keep you safe. It understands you. It senses what happened inside the cabin and around the vehicle. It even cares about you. That is the kind of future we are heading to. Our strategy actually is very crystal clear. Expand from the safety to convenient and shifting to empathetic AI. At the center of this evolution is a recognizer, the engine that drives every transformation. The first phase is the safety. We are already addressing the global safety regulation with proven technologies like DMS, IMS, and vital sensing as explained by Dr. Bach. And this is more than just a starting point. Because without reliable, reusable recognition technologies, I believe you cannot build the next level of the innovation in a cost-effective way. Next comes the convenient and advanced safety. Here is the key. Here is the multimodal recognizer and contextual understanding. Imagine a camera, radar, and audio working together seamlessly, fusing into one intelligent system. The vehicle doesn't just see, it understands the context, and that enables differentiated context-aware experience that go far beyond the safety. Finally, reaching to empathetic AI. This is where the vehicle moves beyond just transportation. It becomes proactive, intuitive, and me-centric by understanding these drivers and passengers' status, intention, and even emotional conditions based on the personal context. The car transforms into the partner, one that understands your needs and create an environment you truly want to be in. This is what we call empathetic interaction, and it defines what mobility means from us. Well, now let's unpack the architecture of LG Mobility AI solution. At LG, we believe that expanding from safety to experience, starting with the one key question: how we understand user intention and providing personalized user interaction. Well, simply collecting data doesn't solve this problem. As the vehicles become more connected and the amount of the data grows exponentially, and in the cabin, even though it is a limited space, still countlessly complex situations can occur. If the system cannot understand the intention or needs like a contextual meaning from this data, we answer with a just possibly like, just a bit smarter reaction, not true intelligence. This is at the core core technical challenges in creating a true empathetic mobility companion. Well, to tackle this, we built an architecture based on the three core AI technologies working seamlessly together. First, recognizer AI. Acting like vehicle's eyes and ears. Capture the driving environment, the driver, and the passengers using multimodal sensors, tracking gaze, facial expression, emotion, voice, and biometric signals, and so on. And here's the key. Multimodality shall be supported, and all inputs are synchronized and processed in real time. Second, insider AI. Served as a brain, interprets all this data to understand the context and intent. At its core is a multimodal context engine that doesn't rely on fixed pre-trained models. Instead, it builds its own contextual database kind of dynamically, meaning that you can have your own model. And it has a module for personalization, leveraging LG's rich heritage in consumer electronics to tailor experience for each individual user. Well, for also safety critical function, latency and isolation are critical, as you may know. Like ISO 26262, safety related functions are executed in a freedom of interference manner to guarantee reliability and then compliance. Finally, last one is Illustrator. This is the voice and personality of the vehicle. Its multimodal output encoder enables interaction through the lights, voice feedback, display, and even vehicle control. Responses are delivered in a most natural, immersive way, adapted to the user situation, creating a true human-centric experience. This is how LG transformed a car from the machine into the empathetic companion, the partner that doesn't just react, but understands and even cares. Well, next slide. Now, due to kind of limited time and frankly security reasons, I cannot disclose every experience we are preparing. But let me give you a glimpse. We call What's That? Here's the short video clip demonstrating an example of the convenience feature inside of the vehicle. Let's watch it together.
Oh, what's that?
Cheonseongdae is an ancient astronomical observatory in Korea built around 1400 years ago.
That's cool.
What does that mean?
That sign means you should not overtake.
Well, to be honest, now I know what you might be thinking. Many companies honestly are working on this similar feature. This kind of similar features, right? And you are very correct. But this is where we stand apart. We leverage our field-proven gaze detection technology combined with outkeeping sensing to eliminate unnecessary multi-step dialogues and make interaction more effective and precise. Then I'm going to talk about more details in the later slides. Well, this might sound like a glimpse into the distant future, but at LG, we are already becoming reality. Here's how. Using multimodal recognition, including the user gaze, our AI interprets intention and response intelligently. Let me paint a picture. Imagine you are visiting Korea for the first time and you are driving, that you see the road sign in Korea that you don't know, or maybe interesting advertisement or sign, but you just passed by and you missed it. Or perhaps you noticed something unusual while driving. With our solution, just your gaze and your voice just enough to get you the right information. The system understands what you need and provides the information. Let's see the kind of our demo.
방금 지나간 광고 뭐야?
방금 지나간 광고는 뮤지컬 에 관한 것입니다. 이 뮤지컬은 서울에서 공연될 예정입니다.
서울 어디서 하는 거야? 지금 예매 가능해?
뮤지컬은 서울에서 2025년 7월 26일부터 10월 25일까지 LG아트센터에서 공연됩니다. 인터파크와 LG아트센터를 통해 예매가 가능하며 일부 날짜는 매진되었거나 좌석이 제한적일 수 있습니다.
Well, what you just saw was a real vehicle demo. And I'm sorry for Korean though. Next time I'm gonna prefer the English version. So even though the billboard sign is in the video was that you just passed, our system recognized your needs and delivered right information in real time, in context, and without distraction. Now let's take a closer look at how this experience evolves according to our roadmap. Traditionally, if you wanted to know about something outside of your car, you had to rely on map-based POI search, static, generate information, nothing more. But with our solution, we go beyond that. By contextual understanding, we deliver dynamic, gaze-driven, and contextual information without distracting the driver. For example, in this case, for the off lane, it also confirms occupancy in a real time using in-cabin sensing solution to ensure you are legally eligible to the home lane. And this is just beginning. The next step is empathetic AI, where the system to personalize you. It understands your needs based on the personalized data. For example, during the rush hour, the system checked your question history, travel or commute pattern, calendar, and live traffic. Our AI understands you, and by leveraging multimodal signals, the vehicle can proactively suggest what matters most to you, like me-centric guidance. Well, here now let's shift gears and look at the example focused on the safety, not convenience feature. And just like before, to help you understand the concept, let's watch the short video clip together.
Watch out! The safety assistant mode is being activated automatically.
Yeah, go to the next page. Well, I hope you get some of the kind of idea about from our safety assistance video clip. And then let's take one more step down into the components. And recognizer is where multimodal sensing turns into true understanding, driver intents, and complex behavior all aligned with the driving context. This demo, left side, shows some of the use case for our safety assistance. For example, it can detect situation like dropping food and assert, or the passenger interference with the steering wheel. Well, applying makeup, you can see later on, that is not a safety critical case. It is just like here to show coverage of our recognizers for different use cases. Now moving to Insider AI. This is where the safety assistance engine evaluates the risk and determines the correct response to mitigate the risk, situation by situation, person by person. For example, if the driver suddenly encounters sickness, the system can take appropriate action accordingly. Likewise, let's take a look into how this evolves according to our roadmap as well. Traditionally, safety systems rely on simple detection. Visual alerts for distraction and warning, and when you hands off or eyes off on the road. That is actually a really foundation and important, but limited. With our solution, we move to the next level, advanced safety with a contextual understanding. Instead of just detecting what your eyes are off on the road or even on the road, it really doesn't matter. It understands what happened inside in a cabin and why. It is a voluntary, like on a phone texting, applying the makeup, or involuntary, like on a sudden sickness, a sudden inattention, like on a risky situation. This enables a saving life if human fails. From just wanting to proactive ADAS adjustment or ways tailored to this situation. And then comes empathetic mode, empathetic AI. Here the empathy mode, I say. Here the system learns your pattern over time. Imagine this. You often drink coffee during your morning commute. This system may gives you an early warning and stabilize the vehicle through the kind of vehicle control adjustment. And it can even monitor your condition over time to detect health risk before they become a hazardous event or hazardous serious problem. It enables you to stay cautious before you even realize you need to. So now you might have the question. Let's say you might be wondering, what makes all of this possible? How do we turn simple sensing into intelligent, empathetic interaction? Let's take a brief introduction about core technologies behind LG Mobility AI solution. One of the core technologies we emphasize is our multimodal recognizer. It is about ability to seamlessly fuse the data from range of the sensors, not just camera, but also kind of voice, microphone, radar, and more, and through the advanced multimodal integration. And here's the key. This isn't about collecting data. It is about building a context that enables accurate, complicated scene understanding, turning raw signal into meaningful insights. Let me introduce the second key elements that multimodal context engine, or we call MCE. MCE is a real-time engine that analyzes multimodal signals using a retrieval augmented generation, RAG. It instantly generates well-defined prompt for contextual understanding, enabling seamless interaction with the various cloud-based LLMs. Without being locked into the specific model, this allows OEMs to use their own models and minimize data traffic to the cloud, reducing dependency and lowering cost. Also, about customer specific use case you may need. Well, in that case, we propose handling them directly on device as much as possible, which not only improves the application scalability, but also contributes to cost efficiency. And for safety critical functions, MCE is designed with an isolated architecture to strict safety standards. In short, MCE is the key for, let's say, cost-effective and flexible integration, significantly reducing a burden of adapting to rapidly evolving AI technology for the OEMs. Now, let me introduce the last core technology elements for today. The essence of the empathetic AI mainly about one simple principle, understanding me and responding in a way that feels personalized and reflects the current situation. To achieve this, LG is applying its long-standing personalization expertise developed through the years of the innovation in the home appliance business. And this is reflected in our user preference engine for vehicle domain, which learns and adapt to individual user behavior and needs and link to user preference. Complementing this is a multimodal output encoder, a lightweighted model designed to dynamically prioritize information based on user context It ensures that communication between the most appropriate way for the current driving, the driver, in-cabin situation. Well, given the limited time, I will not go into further details here, but you may find out more details in our paper presented at HCI 2025. Designing user-centered multimodal output strategy for driver AI assistance interaction. So you can click on, or you can check on the site. Then you can take a look, and then you can get more. You can find out more detailed information on the paper. Well, for the last session, I'm gonna a little bit touch about why LGE. As you've seen today, LG should a reliable partner that delivers both safety and differentiated experience. Our DNA. Our DNA is our DNA for seamless integrating the newest and most advanced AI technology empowers customer to lead the next generation of the mobility. This isn't just a vision. It is a roadmap built on proven safety technologies expanding into future-ready in-cabin experience. With a flexible integration architecture and hardware-software integration expertise, LG enables optimized performance and customer-centric flexible solution. And most importantly, our user-centric personalization is one of our key DNA that continues to define LG even in the mobility. Also in Korea, LG AI Research Institute is recognized as one of the most advanced AI institute with a global top-tier researchers driving innovation every day. We are continuously developing in-house AI models that compete with global leaders like OpenAI and Google, so on, others as well. Expanding cross-domain and evolving rapidly, the core AI capability is not just technical asset. It is becoming LG's most powerful competitive edge for the future. This is my last slide, and given a time limit and nature of the this public setting, we couldn't touch every technical detail today. But if there is anyone who wants to go deeper and share your roadmap for the next generation of the future mobility, please reach out. I think where you find us, LinkedIn, email, or direct message anytime. We would be super happy to continue the conversation. Well, thank you for your time, and I hope to meet you soon again. Thank you very much, and thank you for listening.
Thank you.
Thank you.
All right, thank you, Youngkyung and Minkyu, for a great presentation. Now, as I mentioned at the start, we still do have time for a brief Q&A. The first question that I have for you guys is this. Does LG's Mobility AI solution currently have engaged customers, and when can we expect to see the product on the road?
Oh, that's a good question. Thanks for asking for this. Well, several key use cases of our LG Mobility AI solution are already undergoing the POC. I cannot disclose the kind of specific name, as you may know, but with our global OEMs, we are working on this. And then also, many global OEMs are actively being discussed. I hope that this might be an answer to you.
All right, and the other question I have, I'm curious which LLM models LG prefers or is considering for its solutions.
Well, that is also a pretty good question. Thanks for asking. As mentioned earlier, LG Mobility AI solution is not locked into any specific cloud LLM model. It doesn't have to be GPT, doesn't have to be Gemini, doesn't have to be whatever model. It can be flexibly integrated with the LLM preferred by OEM or you, making LLM agnostic, we say, even OS agnostic. So that's the reason we can provide, or we are saying that we provide OS agnostic kind of AI platform or framework to integrate it your application on device. So key components enabling this is the on-device multimodal context engine and our framework running on your own device. So I think it enables you to run whatever model that you would like to choose.
All right, and with that, I would like to bring this webinar to a close. I'd like to thank Youngkyung and Minkyu one last time for sharing an excellent presentation with us today, and of course to LG for its role in making today's event possible. Thanks also to our audience for your questions and interest in today's event. As always, it's much appreciated. Now, one last time, everyone, we will be making an on-demand version of this webinar available as soon as possible. But for now, thank you for tuning in, and goodbye.
Thank you very much. Thank you. Ciao.
Bye-bye.
Bye-bye.